Hello, welcome to my dynamics videos on the new preliminary physics course. I'm going to be discussing all the syllabus dot points from dynamics in this playlist. So if you haven't subscribed to my channel, please. I've made a Kinematics playlist or PowerPoint and it's attached to this YouTube channel. And if you like some of the videos, then hit a like. If you don't, dislike. I like any feedback. I've also got exam style questions at the end of each of these videos. So just if you're interested in the exam style question or how to find an answer, then stay tuned towards the end of the videos. So first I'll discuss the theory and then the exam style question. So let's look at A. Using Newton's laws of motion, discuss equilibrium interactions between two or more objects that result in a change. So let's have a look here. What does equilibrium mean? It is a body that is at rest or is moving with uniform velocity. Now we can break these equilibrium into two different types: static equilibrium or dynamic equilibrium. So static equilibrium is simply just if all the forces on a body add to zero, or if the body is at rest. So a book resting on a table, all the forces will be zero, static. Dynamic equilibrium is if all the forces on the body add to zero, but they're moving, if the body is moving in constant velocity. So a car moving on cruise control in a straight line on a straight road. Alright, let's have a look here at the next theory or the outcomes for this syllabus dot point. So it's asking us to describe contact forces and forces at a distance, or field forces basically. So contact forces are there in a table, and forces that act at a distance such as gravitational, electric, magnetic force are there on the right hand column. Okay, I'm not going to explain too many of them because I've got a slide that describes each of those and you can see that now. So applied force, normal force, frictional force, air resistance, tension, and spring force are all contact forces. So that's when the two forces are in contact with each other, like our hands rubbing together, which is frictional force, as an example. Now, forces that act at a field is gravitational force, electric forces, and magnetic forces. You may have done that classic experiment in junior science where you've got the iron filings sprinkled on different magnets polarity, so north-north, north-south, and so on, when they're attracting and repelling. Alright, let's have a look here at our exam style question. So I've got a question here which basically says, draw in and label vector arrows on the images to represent any contact forces involved. And there's going to be several images I'm going to discuss in this video. So the first one here is when they're tugging a wall on both sides, or tug of war, or tugging a rope on both sides, sorry. So if you look here, you've got two students on either side tugging that rope, and you can see now what are the forces at play. So the one in the middle, let's look at symmetry, is tension of the rope. So you can see the tension, the vectors go both ways. You got normal force on either side, which is the body's the earth reacting to the weight force acting down, and you got the pull acting on either side of those students. So let's have a look now at another diagram of a man pushing a block up an inclined plane. So you can see here now that we've got the person, or the gentleman, pushing a block, which is the push arrow, friction, which is frictional force backwards, a contact force. You got the normal reaction of the block going up and the weight force of the block acting down of gravity. You got the normal force and the weight force of the person again. So you can see there are some examples of equilibrium and looking at vector diagrams to represent those equilibrium states, but also looking at forces as a contact and as a field. Okay, tune into my other videos that I'm going to be doing shortly. I'm going to be looking at vector diagrams in my next video, when I'm looking at F equals ma, and then I'm going to be looking at friction, and then I'm going to be looking at vector addition, and then exploring a very difficult question when you've got the pulleys acting on a system, okay, in a static equilibrium question.